Okay, thank you. So my name's Tom Whitwell. I design Music Thing Modular, and today I'm going to talk about a new thing I have designed, and I'm going to talk about the sort of process of how you go from having an idea and think I'd like to make something to how you find yourself kind of a year later at an event like this with a whole bunch of them on a table and people looking at them and talking about them. It's become a kind of real physical thing. Um, so this is the thing I'm talking about, which is I'll kind of go through it a little bit more, but essentially it's a kind of all-in-one modular synthesizer that you can pick up and carry around, and it's relatively cheap. You can buy a kit to make it for about 400 quid. And I'll talk through the bits it does, but that's essentially what I'm talking about today. Um, and actually, before I do that, I'll just give you a little bit of background about me. So my background was I am not an electrical engineer. I have no background in kind of maths or physics or any of that sort of thing. I trained as a journalist. I worked as a journalist for many years. I was a magazine editor at magazines like The Face and Mixmag for the older people in the audience. And then I went to work for the Times newspaper for the even older people in the audience. And then for the last sort of 12 years, I've been working as an innovation consultant, which I won't go into too much. But at the same time, I've been doing Music Thing Modular. So I've been designing modular synth kind of modules. And I sort of learned how to do that by going to a DIY workshop, by reading a lot online, and just by step learning how to do things and how to make things and how to get things manufactured, all of those things. And sort of this thing here that I've made is by far the most complicated thing I've ever designed. Inside this are about, I think, 750 tiny electronic kind of active components. On the panel, there's obviously loads of knobs and switches and buttons. And it's kind of, I suppose, for me, what I find sort of amazing when I look back is how sort of 12 years ago, I hadn't really soldered anything, made anything. But over that time, doing stuff kind of in the mornings or doing stuff in the evening before going to bed, you can kind of learn how to do something that to me seems kind of extraordinarily complicated. So I'll talk through the sort of journey of this thing and how I ended up making this. So these are the sort of things I was designing before. So individual little kind of synth modules like this. That's a sequencer I did called a Turing machine, and a thing called a radio music there. So this was 2016, so 8 years ago. I went to a big conference in Berlin, the Loop conference in Berlin, and I made this little case in a lunchbox. A friend of mine made the box thing. I put together this little case, and it was really nice having a very small little system that you could play with. And it had a little headphone amplifier here, so you could hear it. You could run off a battery, so you could kind of carry it around. And I really liked having that. And then I wrote this article about just using that and writing some code to give kind of instructions and using that to record a bunch of little bits of music that you put together and you can kind of say is an album. So I wrote this article saying I did this, I had this little lunchbox system, and I made an album. And that was 2016. Then, about 18 months ago, I got this email, which is a fantastic, amazing email to get, saying, would you come to Cornwall and run a residency for 12 people in a beautiful location? And he said he basically read that article and thought that would be an interesting thing to do for a residency. And this was a guy called Dion Starr, who's teaches at the art school in Falmouth. So I said, great, I would love to do that, it'd be fantastic. And a few months later, we went and sat in this pub in Falmouth, looking at this beautiful view, and started planning that event and working out how we were going to do it. And one of the questions we kind of both had was, well, what are people going to use in that event? Are people going to bring their own gear? Are we going to lend them stuff? How's it going to work? And I think Dion said, yeah, it'd be quite nice if everyone had the same thing. And I sort of heard that and was like, that would be quite good. And I, at the time, was just about to start a sabbatical, was taking a year off my day job. And I thought, well, maybe I could actually do that. And that evening, I went back and made these notes, which was kind of, what is this supposed to be? So I won't go through all these in detail, but it was like, it's a toolkit. It's like something that can change rapidly between outputs. So it's not like it does one thing. The idea, you turn a couple of knobs and the whole thing will change completely. A sort of mixture of, I said gestural, very pretentious word, but like big knobs and small knobs, essentially. The idea that it uses other sound sources, so it's not something that you're supposed to use for everything. It's like everyone's got stuff, like they've got drum machines or laptops or little Volca boxes that make noises. The idea you could take those things and plug them into something like this. So this is the kind of notes of like, it would be quite nice to make something like that. And then a few bits at the bottom about what it might have in it, but more, what's the point of it? Then I started sort of sketching and kind of making stuff in Illustrator. This is just like pulling together bits of parts of what they might do. And you can see kind of drawing around it, things like, oh, maybe it should have a stereo input here. Maybe it needs a clock. Maybe you could have little connections on the back so you could add things to it. And at this point, it was going to be called Close Enough, or Nearly, maybe. So that's the kind of, a big part of the process is just kind of thinking visually and physically about like what is the interface? What is the thing that you sort of use as a human with it? And then at the same time, you start trying to, there's lots of things in there, some things I knew, something I didn't know. You start trying to think, how would I make that work? So this is the kind of workbench. This is where you can kind of put components together and put a switch together and see if something works. And then eventually, look, the little lights are flashing. That's the moment. I think that's the kind of envelopes and slopes thing. So if I'm really uncertain about a circuit, I will create something like this and try and put it together and see if it will work. So you're doing all these things the same. You're kind of sketching. You're kind of thinking about what it needs to do. You're making bits of circuits. One of the things that's in this device is you can plug in little kind of program cards that will do different things. So they might make something into a reverb or make it into a sequencer or make it into something else. And that was not a thing that normally kind of exists. That's not a thing that is sort of you're supposed to do. So this was a kind of computer, off-the-shelf little computer, and I've taken these tiny little wires here, soldered into there, put them into this kind of SD card connector to see, can it actually talk to this? And literally, you write a bit of code, so you put one card in, that lights red, you put that card and it lights up blue, and it was like, okay, this does actually work. This kind of weird idea seems to kind of work. So I could have a little device where you put in different program cards and they do different things. So those are some of the very sort of physical things you're doing. You also spend a lot of time in this software. This is software called Falstad. I say it's software, it's literally a website. You can go and see it immediately. And you kind of mock up the circuit. So you say, these resistors and capacitors and things, will they do what I need it to do? And what's amazing is you do this, and I will play with this for ages and kind of fiddling with these values. When you finally build it, it kind of works. It does. the sort of simulation does match the output, and so it's a really good way of kind of sketching out ideas before having to make them sort of physically. The other thing I'm doing is kind of talking to people all the way through. So this is my friend James, and I went to see him in a cafe in Brockley and said, I'm making this thing, what do you think? What does it, do you understand it when you look at it? Does it make sense to you? But one important thing is to say is, this is what he was actually looking at. So I spent quite a lot of time going around talking to people in cafes with a little sheet of paper. And I remember Alex, Mylar Melodies, who's presumably not here because he said he had a better. He is there, hello. I remember I spoke to you, showed you this box, And I always remember he looked at it and said, well, it's very intuitive. And I said, it is for you and it is for me, but I'm not sure for a real civilian how a box with 58 sockets and switches on it is going to be terribly intuitive. But that's kind of the goal. We would like it to be that. Then the other thing I started doing is trying to build a kind of community, trying to recruit people, because I am not a strong or confident coder. I can kind of just about do enough to make things happen. But I realized I was going to have this thing with the little program cards. I needed to find people who wanted to do that. So I got a mailing list and I said, is anyone interested in this? And started making these kind of prototypes and this very sort of simple documentation, sending that out to people. And immediately this little kind of community developed and people started doing kind of amazing things with it. And that was a real kind of sort of blossoming moment for me to see this kind of kit that I'd made that did things that I could think of. Suddenly there were other people thinking about it and other people making things to work and other people saying, you can make this work better by doing this. And then I was able to kind of work with them and improve it. So that kind of collaboration is important, which we'll come back to. One of the things to say is this stuff is really, really complicated sometimes. This is notes that I was using for designing. There's a kind of power supply in the back that takes USB power and turns it into the power you need for a synth. And I read through all the instructions. You basically follow a load of very detailed instructions and put in all the things you need it to do, and it says this is how it should be. And I remember while I was doing this, just going, what on earth am I doing? This is, I felt like I was a long way through the rabbit hole by that stage. And then you put it together and send it off for the circuit boards to be made, and it comes back and you plug it in and it works and the lights flash and it does what you wanted. So that was very pleasing. And then again, the kind of intensity, this is the circuit board for that computer part. And the thing with this is you're obviously designing this on a computer, but fundamentally you, as a human, are designing it. And I can see some people in the audience who do this. And it's a really kind of, I really enjoy it. It's a very kind of sort of meditative kind of process. You sit down and you've basically got all these bits with little lines between them saying you're going to need to connect this to this and this. And then it's your job to connect them all up on 2 layers, and you kind of knit between the layers. And you need to get it to work. And then sometimes you do all this and then you say, oh, actually this output here is a bit noisy because you've run this trace through here and it's going past something else. So it's a really kind of intense, very, kind of meditative. I remember talking to Emily, who designed Mutable Instruments, and she said this was the only bit that she didn't do kind of in an office or in a workshop. She would do this just on the sofa. You kind of just sit down, start doing it, and then you find like 4 hours later you look up and suddenly all these things are connected together, and you're like, how did that happen? So the headline for all that is that when I share pictures like this on Instagram, suggest this very kind of calm and elegant thing, it's all nonsense. It's not like that at all. It's much more chaotic, much more disorganized. So I thought I'd talk about things I learned along the way. The first one was this. Look, there he is. The first one, and is Elisa here? No, she might be here. That one there. Anyway, the thing that made this possible. So the last thing I designed took me 4 years to make, and that was partly because of like COVID, but it was because I just wasn't really focused on it. With this, I knew that on, I can't remember the date, whatever it was, the 20th of April, 2024, either I would say, oh, I'm sorry, it hasn't quite worked, you're going to need to bring your own stuff, or I was going to have a bunch of people and a pile of these things, and they were going to have them to use and try. And that point of having a deadline, it was just incredibly kind of powerful and kind of motivating, and just sort of powered the thing through. So doing something without a deadline is much harder. The second thing was this idea of having a brief. So I read a fantastic piece about Robert Caro, who's a novelist, not a novelist, he writes non-fiction books. He writes these enormous kind of political biographies. And he said the thing he always does at the start is spends like a couple of weeks writing a couple of paragraphs explaining what the book is for and what the point of it is. And I found this isn't quite as good as that. It's not really properly paragraphs, but these sorts of things that were just like to test against. These were sort of features and stuff, and that was fine, but it was much more like looking back and saying, well, can you do rapid changes? Is it neutral about genre, or is it just sound like a particular genre? So having that brief was really useful. This was kind of January. I was talking to Bogdan, who's the producer. He was kind of interested in it, and I was talking to him about stuff, this sort of back channel, and he said, what is your intention with this device? Which was such an amazing kind of question, and that was, I think, the Friday, and this was the kind of Monday. And I really was kind of pondering it all weekend. I was like, what am I trying to do? And I wrote him this note. I think my intention is to make something useful and open. Open is connecting it to other things, processing it, connecting two devices together and kind of improvising together, something, again, we did in Cornwall. Open because anyone who can write code and is interested can write code for this. They can sell those chips. They can do what they want with it. It's kind of a separate thing. And so for me, it was brilliant to write, and this kind of block of text, again, is something that I've kind of held on to and will look back at and say, am I kind of being true to that? And being asked that question was really useful. The other thing I did, which is I feel kind of slightly kind of uncomfortable talking about it. Again, this was, I think, probably January this year, where I was very much like, I'm definitely going to do this, but I've still got an awful lot of questions to answer. I actually sat down and wrote a sort of 3-page, like, fictional story about this device. And the story was like in the 70s, and it was like, it was essentially, I feel really embarrassed about it, because it's kind of very like weird made up story about essentially kind of sort of British synthesizer people from the 70s, and then you had kind of computers started to come along in the late 70s, and somebody kind of bolting the two of them together, and what that would have meant if that had existed. And anyway, that was a kind of weird thing I did myself, but it meant it changed the way I thought about the device quite a lot. It meant I was more ambitious for what it would be. It meant I could think, this isn't a device with the greatest of respect for just the people in this room. It was a device for kind of broader kind of community of what it's it like for sort of, how would this work for a musician who'd never done something like this before. So it was a really interesting exercise. I would very much recommend doing it. But yeah, it's quite weird. The other thing I really struggled with during this process, and I talked to a lot of people about this, was when you have failures in this, and again, I'm kind of looking at people I know who do this stuff, failures in this kind of electronics can be very, very kind of binary. I was talking to somebody who I work with a lot, and she was saying, well, you've done things that don't work, and you're used to that. In this, it's like you spend weeks designing something, you send it off to be manufactured, it comes back, and you're so excited, and you're like, this is going to work, and you plug it in, and just something ridiculous happens. And it's like completely binary. It's like it just doesn't do the thing. This is actually the back of that. There's a little bit in the synth that has little buttons you press, and the buttons latch. This came back, and you just press the buttons, and they just turned off, and it just completely didn't work. And I found that really difficult. You were just like, this is completely sort of just, what am I doing? You feel like a complete, I always feel like an imposter because I'm not a proper engineer or whatever. And I think the way I kind of learned to cope with it was just by really kind of thinking that through and thinking, actually, I shouldn't take this personally. I shouldn't feel like I can't do it. I should fix it and send one off. Also, I learned to generally order 2 prototypes rather than 20 prototypes because they're not going to work, so don't get more and think you're going to do something useful with them. Then the kind of final thing for this was just kind of collaboration. I've sort of, in what I've done, I've had sort of one really strong collaboration, which was with Thonk, which is the company in Brighton that sort of manufactures what I do. And that has been an amazing collaboration over like 12 years. But with this, again, when I was kind of thinking about it, I don't need to do this all myself. I don't need to come up with everything. One specific thing was when I was designing the filter, and basically I just took like an MS-20 filter and tried that. It didn't really work very well. It wasn't very good. And I was like, well, Philip, who does God's Box, has designed a fantastic filter that I really like, which is this humpback filter that's a Thunk product. So I just contacted him and said, can I use your thing in my thing? And we'll work out some money at some point and make that happen. And he was delighted and was really positive. And then I had like Thea, who does Winter Bloom Modular. She is a kind of genius at KiCad, which is some of the software that we sometimes use. I was like, I don't need to sit and watch hours of YouTube videos to work this out myself. I will ring her up and I will pay her to teach me it kind of one-to-one. I'm doing this professionally, I can do that. And that was amazing, she did it. Then I was designing the panel and I was like, this is really complicated, this panel. There's a lot on it. All the ones I did just looked a bit shit. And I was like, who is the best sort of typographer and graphic designer I know, who's Alex, who is the creative director of The Guardian, so he's quite fancy. Met him and I was like, can you give me some advice about this? And he very kindly understood that as, shall I go and make this for you and design it? And that again, and the collaboration there was really interesting. He went and designed it, and it was his design, it wasn't my design. And when it first arrived, I was like, that looks a bit weird. That's not how I'd have done it. He's got these little circles everywhere. It's like doesn't look like me. But very, after, I deliberately kind of looked at it and lived with it for a few days and was like, this is really good. This works really well. And then we went back and forth and revised it as different versions had come. And so overall, that's a very long way to say this kind of collaboration for me has been really kind of powerful as a shift to just saying, I'm not going to try and do this myself. I'm going to try and do it with other people. And the kind of social embarrassment of doing that, or the kind of hesitations of how will money work, or will they want to do it, is all massively less important than just the benefit you get from actually working with people. So I think that was the last of my little slides. Yes, is the last of my little slides. So if we can now shift this to here, wink. Okay. Now, I have never really done one of these kind of demonstrations to people before, and I am not a musician. So I'm going to try and show you a bit about what it does, but don't expect too much. So there is the device. So everyone says, does it come in a box? And yes, it does come in the box. The box is kind of part of the thing. If I just talk through by pointing kind of what everything is. So essentially kind of from here on is a kind of toolkit of analog stuff that you can use to make sound. So you've got two oscillators, it's kind of mirrored, so that's one oscillator, that's another oscillator. Two filters, again kind of mirrored. These I call them slopes, and you can use them as like, they make voltages move in slopes. So you can use it as an envelope generator, you can use it as a kind of LFO, you can use it to change how fast a signal moves. So if you've got like you could just about use them as an envelope follower, so you put a drum sound into it and it would kind of follow that sound. Then you've got, that is just a very simple stereo in, and is one of the most simple, straightforward things, but is really useful. You plug in your phone or your laptop or whatever, and it produces a couple of modular outputs there that you can then filter or distort, or you can put in the ring modulator, which is here, which again is a real kind of old school. It does give you an immediate kind of old school, space science fiction vibe, but it's really nice for kind of processing things through it. This device here is for guitar pedals. So if you've got a guitar pedal, you plug it in here, and then you can blend it into what you're doing. There is also, I don't know if I can do this, if you can see it on the screen. Let's see. Just about. So there is, I'm not going to try and refocus it. That's like a 9-volt power out, so you can plug your guitar pedals in there straight away. And the whole thing is powered, well, I've got it out, by USB up there. So you can plug it into, I mean, it's now plugged into a Mac laptop charger there. But you've also got there the sort of 20 volts, those kind of barrel power. So if you prefer those sorts of chunkier power supplies, you can use that. But it was really, the USB means it's very portable, so you can have the whole thing running off a battery. Where it's got to here, this thing is a, it's called amplifier, but it's a contact mic. So if I tap it, you can just about see that signal is coming through. So you can actually hear all of the kind of, I'll plug it in a moment, all of the kind of switches and controls that make a sound come out through that. But also you can plug a signal into it and you can kind of distort it. This thing here, I'll talk about when I'm demonstrating it. This is basically like a keyboard almost. And then you've got a mixer here, a stereo mixer there. So that's the analog side. Then this is the computer, and this runs on, let's see if you can see that. I should really try and focus it, but I'm not going to mess with that camera. These are like little tiny program cards. And each of these is the whole kind of memory for the computer. So it's like a mini computer. So if I plug in Turing machine, which is one there, I plug it in, I press the button, little button there, and that now is a sequencer. So that's running out voltages and sequences. If I plugged in reverb, this becomes a reverb kind of effects thing. So it can do kind of anything, is the idea. So that's what it is. Let me try and get it to make a sound. So the patch I'm going to show you is the first patch we did in Cornwall, which is a sine wave to the mixer. So hopefully there is a sound. So this is, I always say, this is essentially, you shouldn't really need anything more than this to make electronic music. So you've got amplitude here, volume, and you've got pitch here. And the first kind of hour we did in Cornwall was just that. So people went away and they recorded little sounds like this, and then they came back and we all listened to them. And it was such a brilliant kind of moment because 12 people did it, and they played it back, and they all sounded different. I mean, they were all quite, wobbly, but they all brought something different to the way they did it. And then we went away, and then they multi-tracked them. And so they came back, and they were just amazing. Some people did these, like, kind of veils of kind of chords moving through different places. We had some were kind of rhythmic, so they'd be doing this the whole time. And they're kind of recording layers of these kind of rhythmic pulses. So I always think when you start with this, it's an incredibly complicated thing that can do lots and lots of different things. But actually, just that patch is a kind of really interesting place to start and to think, what can I do with this? Ideally, if you buy one of these, spend 3 or 4 weeks just with that. Don't plug in anything else. And I have to say, when we did this, some people, David, were like, oh yeah, can I just use the FM? Like, no, just sine waves for now. So let's try putting something else into it. So hopefully this one will give us... So that is a very simple sequence doing that. There we go, that is a sequence with different lengths. Put in that one. There is a a sequence coming out of that. So you then say, well, let's try and actually do something slightly more synthesizery with this. If we take that square wave and then put it through this filter, so you're in straight away kind of that, you're suddenly in quite a different way. You're away from sine waves now. You could start using that envelope and obviously you could have that actually synchronized with the sequence, would probably be more fun. So I'm taking so you're in very kind of simple kind of synthesizer world now, I guess. What I've found this kind of works well, or is a different way of doing it, is by really starting to look at how do you kind of go outside that kind of straightforward world. So if we move into, this is using the ring modulator now. And then we might have another sequencer into there. And then you start, I don't really know how you explain this. You start doing this. You start modulating. You start basically feeding everything back into everything else. And immediately you're in a very, very different world. And you're kind of. So that's what I've found really interesting about using this and about talking to people who aren't kind of modular sort of super geeks with this, is that the fact it's kind of limited, it's relatively limited, it's not like an enormous kind of wall of modular, and the fact that it's physical and tangible is what they find really interesting. So you don't necessarily know what this control is doing, but as you move it, the sound changes a lot. And that thing you remember from the first list of kind of I want small changes or quick changes, big changes that happen quickly and easily. This is kind of an example of that, of how you can go from a very sort of simple pattern like this to this kind of extremely chaotic things in just a couple of changes. So I don't know if that is, we've got about half an hour left, 25 minutes left. I can kind of show you more things that it can do, but I wonder if it would be better, we've got lots of people here, to just open to questions and sort of ideas, and if people want to see things, they can obviously ask them. But I think that probably is the best way to do it. Does anyone have any questions or thoughts? One here, brilliant. Yeah. Yeah, that's a good point. So this is doing a sequencer at the moment. Let's try, there's a reverb chip here. I can't see whether Chris is actually here who designed the reverb chip. Might be. Hello. So Chris is part of the community that sort of got these development kits a while ago. And very quickly was like, okay, here's a reverb. I've put it in the MIDI by mistake there, I could see. Let's try that. Okay, so this is, this takes a bit of patching. One of the things with this is, it is completely modular. It's kind of, there's nothing, I mean, there's a few little connections and all that, but fundamentally, if you don't patch things into it, nothing comes out. So that means you you kind of develop that way of thinking. So I'm going to patch the reverb after the filter. And then let's try just a sine wave into that. Yes, they do go into the ring module. Yeah, that's connected up. So you can hear there's a bit of reverb happening there. Let's try. So you've then got just trying to think where else to patch into that. So you've got a really kind of deep and long reverb there. I'll show you this little keyboard thing now. So what I'm doing with this is patching this thing, which has 4 buttons and 4 outputs, and start patching those into different places around the patch. I'm just really randomly taking those voltages and sending them to places in that patch. So you see, you get kind of quite big controls, make big changes in what's happening. So that's one of the. So you got the reverb. The other cards that it would come with would be there's a MIDI card, which is. I'm not going to try and patch up and demonstrate that, but you put MIDI in and it's through USB from a computer, and that just works as a straightforward kind of MIDI. You can send notes, you can send control voltages, you can send pulses out. But also you can use this part to then send MIDI back to the computer. So you can map that knob to a control on Ableton and be sort of having that two-way connection. So you can change things in Ableton, and you can have Ableton change things in the system here. And it's quite fun if you then take audio out from the laptop and start processing that through here, if that makes sense. Any other questions or thoughts? So you would take the headphone out from your laptop and just put that into the stereo input there. And then you've got 2 channels of audio that you can then, for example, you might just process through the filters. Or you might take a drum loop and be distorting that out. You might take a drum loop and ring mod that through. Go ahead. Yeah, it's an RP2040 chip. So it's for the people who want to program it, you can use anything that works with the Pico, you can use this. So you can do it in Arduino or CircuitPython or whatever. Because there's no firmware at all in the actual computer system. They're not a standard SD card. They're a memory chip in the format of so you have to get them either from us, or that will be completely open, so people can then get those cards made wherever they make circuit boards. So you can use this. You can put a card in. You can connect it to the computer by USB, and you can program like that. I mean, I haven't. There's a coating over the memory chip itself, but in all the testing, we haven't yet seen anything. So it does seem to just work. So, do you want to go ahead? Sorry, yeah, if you go ahead. Not really, no. I mean, I think, that's a question for Steve from Thonk, who I think is there. But I think it was just reaching out to people and saying, I'm doing this thing, are you interested? And I suppose I was very clear that we should have, nobody's going to make lots of money from selling these program cards, but it's something that you could make. I started this as a hobby with benefits, basically. So the idea that if you spend a weekend making one of these cards, and then either you buy a bunch of blank ones from Thonk, or you get some kind of customized ones made in China, then you could sell, if you sell 50 of them at, I don't know whether people will sell for £10, £20, whatever, that sort of feels like what it would be. That's a nice, that's a more lucrative hobby than lots of hobbies. So that's the kind of idea, is how that would work. So things like the design was literally just asking people. So with Alex, he's a friend who was kind of intrigued by the challenge and has a job and stuff himself. So for him, it was just, I think he just found it an interesting thing to do, and he's interested in that world, but not in the details of this world. And I think was just kind of pleased to be involved in something interesting. I am sure we will probably do that at some point. I don't see why we wouldn't. I've no idea. I mean, the exercise you do is you literally just sit down and start thinking about the thing you're doing, and the story that appeared in my head was imagining the kind of EMS London people who by the mid-70s had basically gone bust because they'd tried to do mad ambitious things. The idea of them having a bunch of stuff knocking around, and then at that stage you had it was a little bit later, but you had things like ZX81s, these kind of British, very kind of primitive computers arriving. And the idea of them kind of lashing those things together and then thinking, well, if that descended in London in the late 70s, who would be using that? Who would be, what would they be doing with it? That was I think it's a really good question. There's not things that I can think of, because it did come quite quickly, I think the size was fixed consciously very quickly. The price was also very much a focus all the way through it. It really was, how do you make the most fun for the least money. You know, I didn't want it to be something that would cost £1,000. And I didn't want it to be so that automatically kind of limits you to quite a lot. So I can't. I suppose there's definitely things like I would have liked to have a way to do something that was more kind of sampling and stuff like that. But you then need quite a lot more stuff, like another SD card, all that sort of thing. I didn't think having a real SD card slot and a fake SD card slot was a very good idea. So I think that would be something. And then I think some way of more of a keyboard than 4 tiny buttons that produce sort of random notes would obviously be another thing, but I couldn't really see a way of getting that in. No, there's a DAC for audio and filtered PWM for the CV. Yes. So I was thinking about that when I saw that sketch. That must have come very, very early. I don't consciously remember thinking of that. I do remember talking to a person in that kind of modular scene who was like, I think this is terrible, this doesn't look like a proper modular, you've got to move them down to the bottom and arrange it like that. But I think that because I think also what I really liked about that was you can also obviously play it like this. You can have 2 people playing it at once. So yeah, I actually can't remember. Like the oldest note I could see was that sketch, and I think somehow in my head I had that idea of the mirror thing. I think I very much wanted 2 of everything, so it just came I guess it just came from that. So that specific thing came much more recently. So for a long time, it had like a little sort of tape reels there with the idea that it was a kind of old-fashioned computer and the tape was going in to read the program. That was the kind of idea. As I was working with Alex, who's a designer, I said, you know, this is all up for grabs. You don't need to keep those reels because I did those reels. He designed this bit here. So this is the contact mic, and it's a bit wonky the way it will improve and be a bit sharper. But the idea was this very scribbly kind of texture thing, because he was like, when somebody sees a scribble, you kind of want to touch it, and you get a bit of the sort of texture of the surface. He then went on and did a version of this where this was all very kind of scratchy and scribbly. And I said, I really like the way it looks, but it doesn't feel like the thing sounds. You know, it feels like, obviously you can do very distorted, angry kind of things with it, but you also do a lot of these kind of, you know, bells and a lot of sine waves and stuff. So I literally sent him a little video of sine wavy kind of belly type sound. Actually, what I sent him was a clip of Menkey's Wing Pinger. And I said, this is what I would like it to sound like, that kind of that sort of sound. And he very quickly came back and said, well, what about this? And I think that connection with the idea of it being like tape loops as well was, so that is where that came from brilliant Alex. Yeah, because I think you could possibly do it with an SD card. I myself wouldn't know how to do that. And what you would have to do is build a whole kind of firmware. And this is the sort of moment where somebody in the audience will go, no, you don't need to do that, or this already exists, which is fine. But my limits of my understanding were that you would have to build a kind of firmware that lives on the computer and then reads some kind of very specific codes, language, something, off the card and kind of interprets that. That to me seemed very complicated and difficult and quite hard for a random coder to develop. The thing with this is it's literally the entire memory, everything is on that card. There is no code on that. I mean, I guess there's some code kind of embedded in the processor, but there is nothing on there. So when somebody comes to me and says, well, can I write this in like Rust or something, some weird esoteric language? I'm like, sure, you can do whatever you want with it. And everything you do is stored on that card. The entire memory of the system is stored on that card. And actually, I have just added a little bit of memory on the device. So, for example, when you calibrate it, you can store the calibration between cards. But that was only like weeks ago, I did that. So that was really the idea. And it means if somebody is like, I wrote this card for 8MU, which plugs in that little 8MU MIDI controller and takes the accelerometer data, the kind of movement data, and turns it into voltages, which I imagine is quite a fun thing to plug in. I wrote that in like an afternoon. I mean, it's really basic, simple, kind of hacky code, but it works fine and is an interesting kind of idea. I wanted to make sure that this was as easy for people who want to develop as it possibly could be. So that, I think, was the thinking behind that. It does mean you obviously can't store a terabyte of samples on it. So my sort of start with modular came. So I had done little bits of like Arduino things, and I had made a few like guitar pedals and things in terms of electronics and stuff. And I had 3 friends who said, "Oh, there's this modular show in Vauxhall that Post Modular put on. This was like 2011, maybe 2012. You should come along." And it was this kind of Saturday morning kind of thing where you turned up, and it was the first time I'd seen a Eurorack modular or anything like that. And I was like, this is fine, I don't need to get into this, I don't need to start buying this. And I remember there was 2 things. I remember Ben, my friend, was like, the great thing is it's all in a box, and you turn it on, and you can just do it for like 5 minutes, and then you turn it off, and you go away. And it's not like loads of pedals and guitars and keyboards you have to plug in and stuff. And I was like, oh, that's interesting. He was writing a book at the time. And then he was like, oh, and yeah, you do this kind of DIY stuff. You should do that in modular. That'd be great. People would love that. And I was like, it would be that does sound quite good. So I'd started that, and then quite quickly as I bought things, I then made like a little sequencer, and I made like a reverb, a spring reverb, and then I sort of shared those on Modwiggler and on kind of forums as like sort of little sort of strip board things. You couldn't know how to make circuit boards at that stage, and people sort of liked that. So I then, when I did the initial Turing machine, I kind of published that and said, these are all the parts you need. This is the circuit board design you need. This is this is the design for the panel. You can go away and make this yourself. And then Steve, I don't know if he's still here, he was sat there, said, oh, I'll do a group buy on this, and you can buy it from me instead. And that was essentially how Thonk kind of was born. So the idea of a kind of open source distributed manufacturing was a nice idea, but it was much easier to just buy stuff from him. Yeah, I think it was just from the way I do things. when I use it. I suppose the closest thing would be like make noise stuff. So I've got a what's it called? The make noise big oscillator. No, the DPO. Yeah. So I've got DPO, which is a square wave and a sine wave, which is basically that. Obviously, that's sort of maths. And then I have a QMMG, which is you just use filters for everything. So that's why there's not really any VCOs. You can use the ring mod as a VCO, but I just filter everything out. So that was why I kind of ended up with those. Then I think the idea of the stereo in and the amplifier and the pedal thing was just wanting to have that looking outside. So it's like I've got bits and pieces of stuff around the studio, around the shed. How do I make it so it connects with them, rather than, for example, using that space to put in like a third oscillator or something else? Does that answer your question? Yeah. Did anyone else have another? Yeah. 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 It was a no. It was a really embarrassing thing because Alex is an extremely serious proper designer, and I had designed like a version of the front panel in my normal kind of layout, and I was like, "Yeah, you got to design something where, I mean, it's actually improved a little bit since then. But you've got like a knob here and a knob here that's not quite on the same line as this, and there's a little bit down there, but they're not actually in a straight line, and yeah, you've just got to do that." So yeah, he didn't have any input in that because, as you'll know from doing it, that's just because there's a pot there and there's a pot there and there's a pot there and there's these switches here and there's no other way there's no other way I could work out of arranging it. So yeah, I felt very self-conscious going to him and saying, "Here's a ridiculous arrangement of things. Can you somehow make it work?" So, I mean, it's usually just something that I'd want that doesn't exist or that I can't afford is the kind of core of it in some ways. Or I would just have an idea for something that could exist. So, I mean, the most obvious one of those is the story of the contact mic thing, microphony, which was a contact mic in a panel with a little amplifier behind it and a volume knob and an output. That was just like a joke. Like, wouldn't it be funny? I can do it now. Wouldn't it be funny to be able to hear all the switches and knobs in your system and actually physically like listen to them? And then you can run them through a filter and do things like that with them. That was really the extent of that idea. It was like, that'd be funny, wouldn't it? And then Steve Thong agreed to make some of them, and then we started showing them to people, and they came up with really kind of interesting, quirky things to do with them. So they would take a contact mic, freeze it in a block of ice, and then record the sound of the ice melting. And then people started doing like really nice musical things with it. So then you had like rings and those kind of Carpler Strong sort of delay things. And I remember seeing a video of somebody with a pencil with a rubber on the end, kind of tapping the panel, and this beautiful kind of sound coming out of it. So that idea of you kind of make something that's just because it'll be fun, and then you put it into the world and something amazing happens to it. That then informs kind of with this. Like, I find kind of demoing this really kind of difficult because I'm like, I don't know what you're going to want to do with this. I don't know what you'll come up with, and I'm sure it will be something more interesting. And when I do like a kind of simple, kind of subtractive, here's kind of some blippy sort of baseliney thing, it feels a bit like, well, I don't know. And then we do something really chaotic and noisy. I'm like, well, is this going to make people think this just does chaotic and noisy things? So it's only when you see, and like I saw in Cornwall with two people here who were at that retreat, seeing what they would do with it, suddenly you're like, okay, now it's out there. So when I'm designing something like this, it's trying to sort of kind of not make assumptions and not patronize the audience. I think is a big part of it. You know, I'm not saying it's not like the classic and an amazing instrument, but a microKORG with a knob that says hip hop and R&B and jazz on it. It's like the opposite of that. It's like I don't know. I'm really looking forward to, like, you know, go to Goldsmiths, find some people studying jazz, and give them one of these and find out what they do with it. That's what I find really interesting. So when you buy the kit, you get, so behind this, there's like 4 circuit boards. There's computer, VCO, filter, which is like cursed. Everything was difficult on that board. Mixer, which is very straightforward. And those are populated, and then you've got a back panel, which is obviously the kind of power supply. And so that's got where the USB goes in, the 9 volts comes out, bits and pieces there. So that's completely assembled, the PSU. Those boards have got about 750 components on them, on the surface mount components. What you have to do is put on all these pots, which I can't remember how many there are, but there's like a bunch. And then the switches, and these buttons here, the LEDs, and 58 of the FunkyCon sockets. And you can do them board by board. So like when you're actually doing it, this one is the easiest because it doesn't have any LEDs or any switches, so you kind of get the hang of it from that. And then you probably do computer because it's got some LEDs and only one switch. And then this one's just really fiddly because these switches make it fiddly to put the front panel on. But essentially, you put it together, you assemble each of those boards. And to answer your question, when I do it, so I had to make about 15 of them for the retreat in Cornwall. And it takes me about an hour to do the soldering or so, but I'm obviously quite good at it. We then did a build at Thonk a couple of weeks ago, and it was more like kind of 3 hours probably to do, but that was with a bit of kind of thinking in between. And actually, I think it's a lot quicker. We've now actually got kits from Thonk that have been assembled, so it's quite nice doing it with everything in neat little bags, and it works properly. Then, though, you do the electronics, and you can plug it in and you see it working. Screwing on these fucking nuts. I mean, there's a lot of them. There's 50, I think it's 58 or something. And yeah, you kind of get a little knack of just kind of balancing them on and then twisting it. And then, again, the Thonk people are, oh, you just run your finger along and through. That doesn't work. So that is, that was taking me about another sort of 45 minutes or so of doing that. But by that stage, you've kind of won and everything's working and it's okay. Exactly, you can definitely do that, and it's all kind of assembled in one thing. So, it's. I think it's quite it's like a sort of relatively long build because there's a certain amount to do, but it does go very quickly. And after quite a short amount of time, you've got the actual thing in your hands. It's quite nice. We're slightly over time. If anyone got any other questions, maybe just come up. But otherwise, thank you very much for coming.